Let's imagine that you've got the registry. Let me just change the size of these things here. Let's go for that. So here is the Windows registry. Okay, now let's imagine that there's an entry in the registry, you know, sort of deep inside that's representing the hierarchical namespace there. And this entry here, if it's set to a 1, that partially means let's do certificate revocation list checking. Let's imagine there's another entry. Let's just say it comes off that node in the tree, and that's there. And when that's set to a 1, that also says partially do CRL checking. But let's imagine that we've got the operating system. The operating system is here. And what it does is it checks this number, and it checks this number, and if they're both set to 1, then it will write a 1 into a new value here, which is at this, let's just say this part of the tree. And what that does is that does full CRL check. You know, CRL check is when if you've got a certificate, let's just say you've got a certificate that's protecting your web server for SSL. The certificate revocation list is a list of all certificates that have now been revoked. So you probably wouldn't want to be using certificates which had already been revoked. Okay. So remember what I just said there. I said when this value is set to a 1 and this value is also set to a 1, the operating system itself will set this value to a 1. And that means that you've got certificate revocation list checking. Now let's imagine that something happens and this value gets set to a 0. Let's put it back to brushes. If that now gets set to a 0, whoops, I should have gone to a different color. Then what the operating system does is it checks this one. It checks this one. It sees that they're not both at a 1. And so it sets this value to a 0. To a 0. And that means now that certificate revocation list checking won't be done. Okay? So, let's imagine now that somebody wants to find out whether CRL checking is done. So they've got a bit of code over here. Let's do this in orange. This is their code. And what they do is they call the Windows API, whatever the API is called that can do this. I don't know, let's just say there's one called CRL check. Oh, excuse all these little things happening here. So let's imagine that's the CRL check API. And what that CRL check API does is it checks all of these values to make sure they're all consistent, so that if we've got a 1 and a 1 in there, it will do CRL checking, and if we haven't, it won't. So going through the API is the most thorough way of doing a check, because it will do all the checks that the operating system does. But let's imagine that somebody doesn't know that API, and then they're not even aware of its existence, for example. Then what you might get is somebody who breaks the Windows guidelines, because the guidelines are not to write directly to the registry. And what they do is they write a piece of code here, they put it into a DLL. And what that DLL does is it just sets that value. So let's imagine that the DLL sets that value to a 1. So it's now at a 1, which we know is going to enable CRL checking. And that's great. So we've set that value to a 1. CRL checking is going to work. And that means that your code is going to work. As far as you're concerned, you've written a DLL which writes to the registry directly. It's set that value. Therefore, CRL checking is going to work. However, one thing that you don't know is that the operating system up here is monitoring what's going on in the registry. And it sees that we've got a 1 here, we've got a 0 here, and its rules are only set that value to a 1 when both of the contributing values are a 1. And at the moment, they're a 0. So what does the operating system do? It sets it back to a 0. Where are we? I need to brush. Sets it back to a 0, which means that since you called that API, you have one view of the registry, and the operating system has a different view of the registry, and they're not compatible with each other. So the guideline is, don't go doing things directly into the registry unless they are keys that you own and manage yourself. But don't go doing this kind of stuff. In fact, what you really should be doing is going through APIs. Whenever you go to the registry, you should really be going through APIs to do that. Okay, so it's bad to do that. That's the first point. Okay, so the first point is the registry works in mysterious ways and we shouldn't be modifying it directly. It's somewhat analogous to if you've got, let's just say you've got SAP. Let's say it's running on SQL Server. And let's imagine that somebody wants to modify the way that it works. And so what they do is they just change the database schema, go in there and make a few modifications to the underlying database. That is probably going to cause all sorts of havoc to SAP sat on top of the database. Okay, so let's bear that in mind then. That's one thing. Let's get rid of this. Delete it. Now let's think about the Azure platform. So what we have in the Azure platform, make sure I've got all the right things here, is we've got a host operating system. And on top of that, we have collections of virtual machines. In this case, we've got 4 virtual machines. Now, this wouldn't happen in real life. They wouldn't all be on the same host operating system. They'd all be on different hosts. But let's imagine that they are all on the same host. And then what we do with app service, for example, which is one of the PaaS services, is we've got the operating system here. I suppose at the top of this layer here, we should say we've got the hypervisor, shouldn't we? And then here we've got the operating system. And then in between your code, so this is your code, and the operating system, we've got a framework. Let's do this. So in there, we've got a framework of some description. And that can be PHP, .NET, Java. There's a list of what it can be, actually. I think we can find that, actually. Let me just pause the recording, see if I can find it. Yeah, if I go here, this is an app service I've got running. It's called SQL Injection AI. And this is just an application I've written to demonstrate how SQL injection attacks can work for people. And you can see here we can specify what frameworks we want. So we can run on .NET Framework 4.6, and we could choose a different version if we wanted to. Go back to 3.5. PHP 5.6, 5.5 or 7. Java currently switched off, but we can use Java 7 or Java 8. Python 2.7, 3.4. And then we talk about the different aspects of the platform, you know, whether it's 32 or 64-bit, whether we've got WebSocket switched on. There's a feature called Always On, and there's a thing about the actual managed pipeline, which does all the HTTP processing, all that kind of stuff. But I think the main thing is these bits up here, .NET, PHP, Java, and Python versions. Those are the frameworks that you can write your application to. So let's go back to this picture here. So between your code and the operating system is a framework. So let's expand that out a little bit. Let's go back to the brushes. So let's just take one of these VMs, and it looks like this. And there is your code. There is the operating system, and here is the framework. And one of the things that the framework stops you from doing is having your code to go down into here and then down into the operating system and make changes to the operating system like we just talked about a few moments ago when we were talking about how you really should be using proper APIs to get into the operating system itself. Okay, so the framework is almost like a filter that only lets the good stuff go down into the operating system. Now, it doesn't inspect everything that's going on. So if you write a bad DLL like the one that we just talked about, and you put it here, and you call it from in your code, then the framework isn't going to let you send that request down through to the operating system. So that's one protection that you have from that. Now, if you use one of the authorized APIs, then you're not going to do any damage to the underlying operating system in any case. So in this case, you really shouldn't be putting bad code into your application. And as long as you follow those guidelines, then that's not going to happen. You're not going to have problems with that. And that's the real key to the whole thing, is that if you write some bad code which is going to break some rules and it's going to screw up the underlying operating system, then you can expect bad things to happen. Okay, and that's how we've been operating the app service for about 3 years now. It's by far the most successful of the services. It's the one which is most subject to these kind of problems. But all of the PaaS services run on top of a virtual machine and operate in these kind of ways. So it's one of the reasons why we have frameworks and we have managed code. So the managed code in here, this is all going to be .NET code, and you would have to really you'd have to go write a C++ DLL and get your code in here to call that DLL, and for that DLL to be a bad coded DLL and do bad stuff to the underlying operating system. So you'd kind of have to go out of your way to make this bad. If you were to just follow the proper normal way of doing things, then you're not going to suffer those problems. So hopefully that kind of explains why it is that if you do things properly, you're not going to hit any problems. Okay, thanks for that. There are a couple of articles actually, and let me just pause the recording and I'll find them. Okay, I found some articles, and they are how to update a cloud service, update an Azure service changes during an update, what gets changed, how the thing proceeds across update domains, and so on. What happens when different things happen? What if rolling back any update is a problem? So there's an article here, and you can probably see that link across the top there. There's an article here, which is the list of updates, the changes that have been made. There's an article here, which is an RSS feed of the updates, what guest updates have been made, and then there's how you might debug applications. So there is some information available which should make it possible for you. One thing I should probably point out here, and this is the sort of thing that you probably won't do. Let me just get rid of this diagram here. Let's imagine that you've got an on-premises application which consists of, let me get these brushes again. Here's your on-premises application. It's running on a server in your data center. And what you've done is you've gone to a PaaS service in the cloud. So this is a service, let's just say it's called Web Apps. It's the Web Apps service. That's the service. Then on here, what you might have is your IIS application. And it's very unlikely, well, it wouldn't be particularly recommended that you just pick that application up and move it into there. Because, all the stuff that we talked about earlier, there's lots of protections put in place on web apps, and so it's probably going to break your application. I mean, you might do this as part of your development process, find out what errors you get, fix the errors, and then eventually have it written. But the application that you write for this environment is different to the application that you write for this environment. Sometimes you just copy it and it works fine, but other times there's work that you have to do. So that's unlikely to be something that you would do in a real sense, in a real world. The other one is that you might have an infrastructure as a service, VM running in the cloud, running in Azure. So all of this is Azure. And because that infrastructure as a service VM is, it's not only the moral and the moral equivalent of what's in your environment, it's an actual equivalent because it's just the same thing, just running in our data center. So again, if you were to take this IIS application, sat on the top of it, and try and move that into the web app, you'll be inviting disaster as well, because the same thing, this application will probably be different to this application. Okay, so hopefully you don't do that. Hopefully you start, from the ground up, or you start from a separate project using some of the PaaS services, and you just move your other stuff into IaaS services. Okay, hope that helped. Cheers then.